if you want, you can. The other thing that you can do is if you have more data, what people do is they validate vapor penetration length, sorter mean diameters. You can do a lot of crazy things. It depends on the type of data that you have, but usually there has to be some type of data. It doesn't matter which CFD tool you're using, and it doesn't matter what type of simulation you're doing. You always need to kind of first do a grid dependence test, make sure that you're getting an answer before we select a particular mesh or solution. So in this case, the 4mm base grid that I've selected is based upon several such simulations that I've run over the past 7 to 8 years. And the thing is, if you're using a different turbulence model, things will change completely. So which grid control strategy must be adjusted for grid dependency? That's a great question. So for grid dependency, that depends upon the type of software. So it seems like you have done some type of simulation work. Can you tell me which simulation softwares you're using so that I can kind of give an answer with respect to that? Oops, sorry about that. In the meantime, I'll just answer Nirav Vyas's question. How is this flow of volume how is the spray controlled, Nirav? I'm assuming that's your question. Well, you know the amount of fuel that you need to inject, and you typically give something called as the injection rate profile. Based upon that, you can calculate it. Nitin, if you use Converge, then I'm pretty sure you're familiar with AMR, right? Adaptive Mesh Refinement. So the AMR is a very standard parameter, and there is something called as the subgrid scale parameter, right? There's a velocity parameter and the temperature parameter. I would change that, and that will actually help you out. And if you'll see, at the end of the day, it depends on the type of engine. So if you're simulating a diesel engine, then the combustion process, as you know, is mixing control, which means getting your spray is more important than getting the combustion right. So in that case, what you can do is, in Converge, if you're simulating a diesel engine, you would first put a fixed embedding near the spray, correct? So when you put a fixed embedding near the spray, there's a parameter called embed scale. You can adjust that for 2 or 3 different cases and see how your results are converging. And what you can do is, for adaptive mesh refinement, you can modify the SGS parameter, but you have to be a bit careful in that. But if you can do that, that would be a very consistent way of doing grid dependence test. Nirav Vyas, sir, any books or online resources to learn this software from basics? Maintaining the same base grid, yes. You can, if you have a lot of computing power, Nitin, modifying the base grid is an excellent strategy. The problem is, if you're using adaptive mesh refinement with a base grid, with a different size base grid, your seed solution is going to change. As you know, adaptive mesh refinement, before it kicks in, it takes the SGS values, which are second derivatives, from the base grid. So modifying the base grid is going to affect that SGS field that you have for AMR. So your AMR is going to be different. So there's 2 ways to do it. One is turning off AMR, which would take a hell lot of time, but then you keep on reducing the base grid, and then hopefully you get your results. But even in that, you can actually get into an issue, which is, as you know, you're using a turbulence model, right? And in this case, whenever you use a turbulence model, you have to use the right law of the wall boundary condition, which, as you know, depending upon the turbulence model, if it's a high Reynolds number model, you cannot have a very large, you cannot have a lot of mesh refinement near the wall. I'm hoping you know that. Is that something that you're familiar with, Nitin? I just want to make sure that I'm not getting too deep into the woods here. That's why. Yeah. Okay. So that is another thing. So at the end of the day, with respect to all of these things, right? It's a system that depends on a lot of factors. So here you need to make sure that your mesh refinement is correct, but it should not be too refined. One of the things that people immediately think in CFD, that if I keep on refining, my results should be super accurate. The problem with that is that's not true, especially if you're using a turbulence model. Your turbulence model has that limitation, that is, it is valid only up to a particular grid size. If you make the grid much more refined than that, your wall quantities will be wrong. So with respect to IC engines, it's not a big deal, but the way you will see that effect is it's going to increase, say, the wall heat transfer, which is going to cause a reduction in the peak pressure.